Hello guys, welcome back to Maths African Motives, still on Engineering Science N3. In this platform, we shall be focusing on hydraulics, the question paper of from the question paper of November 2022, where we are given on question number 6, we are given the first part 6.1. We are not going to waste much time on this one. We are given to explain the term static head. So the static head, remember, it's given from the equation that we know. It's actually the combination of the suction head and the delivery head. So you can just write this as, okay, let's just write this as a formula to say the static head is equivalent to the sum of the suction head. That is the sum of the suction. We've got the suction head. All right, you've got the suction head plus the delivery head. Okay, so that's the delivery head. So if you are to check back, we referred this, I refer to the diagram that shows the combination of the two. So this one, it was just for you to explain. All right, so that's 2 marks just to explain. 6.2, we are given that there is a single action suction pump and it's got a ratio of diameter versus the stroke length, which is 3:1. So take note, this is the diameter as to the stroke length, which is 3:4. If the work done by one stroke is 125 joule and the pump is used to pump water to a height of 8 meters, calculate the diameter as well as the stroke length of the piston. Okay, let's just take down the information that we are given, guys. Here, this is our 6.2. So remember that we are given the ratio, right? Let's have this one. We are given the ratio of the length and the diameter. Before here, that's the ratio, okay, between the diameter and the stroke length is 3:4. So that's the diameter as to the stroke length, which is given as 3:4. All right, so remember that ratio can also be written as a fraction. That is the diameter as to the stroke length is equal to 3/4, like this. Okay, so from this you can play around with the formula. I don't know, you're going to express L in terms of D or D in terms of L, but that's what we have for now. And also the work done by one stroke, which is 125 joules. So we also have the work done here, which is 125 joules. And from this information, we're given that it's used to pump water to a height of 8 meters. So that is the height that we are given. All right, so we're given a height of 8 meters. All right, a height of 8 meters. So from this question, we are now asked to calculate the equivalent diameter and the equivalent stroke length. We do not know these two. All right, but we know that from a single pump, if we are given the work done, because we've got the work done here, we know that our work done is taken from the formula where work done is equivalent to the pressure times the given volume. All right, so that's the pressure times the given volume. All right, but do we have the pressure? All right, so we are given the pressure can be taken from the height that we have got here, because we just have the height. We do not have the pressure. So this is the pressure and this is the volume. All right, so we can calculate the pressure where we know that our pressure is equivalent to the density times the gravitational acceleration times the height, that is rho GH, where we know that the density for water from our formula sheet there, we are given the density for water is 1,000, or let me just indicate down here on this table. Okay, let's just check. If you've forgotten this, then you can take this from the table. All right, so for density of water here, we are given that the density of water is 1,000 kgs per cubic meters. So this is the one that you're going to take, which is 1,000. All right, so we need 1,000 here. So this is going to be the density of water, all right, which is 1,000 multiplied to 9.8 for the gravitational acceleration times the height of 8 meters. Okay, so if we multiply this, we are going to obtain 78,400. That's 78,400 in this case, which is the same. We can even write in kilo or you can just leave it like that, which is pascals. Okay, so we have the pressure and the volume. We know that. Let's expand this formula. So our work done is going to be pressure times the volume, where we know that volume is area times stroke length. So this is area times the stroke length, where we know that our area is pi d squared over 4 times the stroke length. All right. So that means in this case, we can manipulate the formula that we are given here. We can work from this formula. We've got two unknown values. We have the work done. Let's list what we have. We have the work done. We have the pressure. We do not have the diameter. We do not have the stroke length. But we are given here a combination or a ratio that we can use between the diameter and the stroke length, that the diameter is equivalent to diameter over length, that's 3 over 4. So it's either you can make D to be the subject or you can make L to be the subject. Since here we've got a D squared, it's easier for you to work with L because you're going to square that L. So please just make sure you can just write L in terms of D, or you can write, I don't know which one is best for you. All right, so let's make L to be the subject in terms of D, because it's easier for us to work with than to make D, there is going to be something else. So we are going to make L the subject. So cross multiply, that's we are going to obtain 4 times D, which is 4D is equal to L times 3, which is 3L. So if you are to make L, divide by 3, that's L in terms of D is 4D over 3. So what I was trying to say is that if you make D the subject, then you have to substitute that D, then you square it, so it's going to be challenging than to make L the subject. Okay, so this is our L in terms of D. So we can substitute this, then we know that we are just left to find D because the equation, we have got everything here. Let's substitute what we have. The work done, remember we are given that our work done is 125, so we're going to have 125 is equal to the pressure that we calculated, 78,400. So we've got 78,400 times pi d squared. We do not have this d over 4 times the stroke length in terms of d, which is 4d over 3. So that's what you're going to have. So in this case, we can now find the value of d by solving the equation that we are given in this case. Okay, the 4 can cancel. So what I need you to do is to combine the values that you are given, or we can just calculate them together here. All right, so how are we going to solve? We can cross multiply 3, multiplies this side because this is the same as over 1. So 3 is going to multiply 125, or you just have to divide. I don't know which way is going to be easier for you. Let me show the calculator so that we can see the method that I'm going to use here. All right, so in this case, I'm going to simplify what is on the left-hand side together. That's 8,400 times pi. Okay, we are going to multiply with pi times the 3 there is same as 1 over 3. Okay, so we're going to multiply it as 1 over 3. So multiply to 1 over 3 like this, which is going to be 600. Okay, so this is what we're going to have. So we're going to have 125. Okay, let's see. So that's 125 is equal to 313,600D. Okay, do we have a pi here? Okay, let's check, guys. The pi is not there. This is pi, not 4. All right, guys, let's check here. This is a pi, so that's shift. We've got a pi here like this. So that's 7,378 this value over pi. Okay, so this is supposed to be like this. 78400 over 3 pi. Okay, then d squared times d, which is going to be d to the exponent of 3. So in order for us to find the value of d, we can divide both sides by this whole expression, which is multiplying to d, this whole part, we divide it to 125. So that means we are going to have d to the exponent of 3, which is 125. We just have to divide 125 divided by that answer that we got. That's 1 comma whatever that we have here to the exponent of -3. So we've got 1 5, 225, something like that, to the x times 10 to the exponent of -3. So to find D is raised to the exponent of 3. So we are supposed to find the cube root of both sides. We find the cube root of both sides there. So that means our D representing the diameter is going to be the cube root of that answer that we got. So that's the cube root of the answer, which is 0.1150 something, which is going to be 0.115. All right, so our D is going to be 0.115. All right, so we've got 0.115. So we must know that this diameter is in meters. All right, it's in meters. So we have got the diameter. So to find the length now, the stroke length, we are going to use the ratio that or the equation for the length. Remember, we indicated here that the length is equivalent to 4D over 3. So which means our length is going to be 4 times D, which is the diameter of 0.115 over 3. So this is going to give us the length. So if you calculate properly, we are going to obtain something like 0.153 meters. So that was going to be your stroke length. So the question was for you to calculate the diameter as well as the stroke length from the given information. All right, then on 6.3, we are now given the following information pertains to a hydraulic press. So that's our hydraulic press that we are given. We are given the force on the lever, which is F, which is 25 Newton, the mechanical advantage, the diameter. We can convert this diameter to meters. That is millimeters. You divide by 1,000, which is going to be 0.025 meters. The diameter on the ram, we divide by 1,000 again, which is going to be 0.105 meters. The stroke height, which is the stroke length, which is given as capital letter H for the stroke length, we divide again by 1,000. That is going to be 0.04 meters. All right. So from the information, the first question on 6.31 is for us to calculate the mass lifted by the hydraulic press. So we know that the mass that is lifted by the hydraulic press, that is the mass that we are going to have from the force that acts on the ram. All right. We know that if we have got the force on the ram, then we can calculate the mass, since the force is equivalent to the mass times the gravitational acceleration. So in this case, in order for us to have the mass, therefore we are just going to divide by G by G. But do we have this force? We do not have. So which means we are now forced to calculate the force on the ram. Then we divide by the gravitational acceleration. Where are we going to have the force on the ram? We do not have this. All right. So we are going back to the relationship that we are given here. We are just given the force on the lever of 25. So this is going to help us now to calculate the force on the plunger. Remember, we have got the plunger and the ram. All right. So the force, the lever, is going to affect our plunger force, which is FP, where we know that it is going to be the force on the lever, which is F, multiplied to the mechanical advantage. So here, guys, you must know your formulas. So that's the force, the lever force here of 25 times the mechanical advantage of 18. So if we multiply this, we are going to obtain 450 Newton. Take note, this is your plunger, but we need the one on the ram. We have a great relationship from our formula sheet. It's given the relationship between the force on the ram and the force on the plunger, which says that the force on the ram divided by the diameter that is on the ram is equivalent to the force on the plunger divided to the diameter that is on the plunger again, but this is D squared and this is also D squared. So this formula you are given. So to find the force on the ram here, the one that is missing, all you need is just multiply by D squared both sides so that you make this to be the subject. So this can cancel. So the force on the ram is going to be FP over D squared times the D squared like this, which is the force on the plunger, the one that we calculated of 450. So that's 450 over D squared. So take note the diameter, the small letter is on the plunger here, which is 0.025. 0.025 meters. That is the small letter B. All right, so we're going to have this as over 0.025 squared times the diameter that is on the ram. On the ram, our diameter is 0.105 squared. Okay, so this is going to give us the force on the ram. So I want you to calculate this from your calculator properly. We must obtain something like 7,938 Newtons. Okay. Now we have got the force that is on the ram, which was the missing value on this formula. So if we have got this value, therefore we can have our mass, because remember we said mass, that's the force on the ram of 7,938 divided by g, which is the gravitational acceleration of 9.8. So if we divide here, we are going to obtain something like 810 kgs. All right, so that is the mass that is lifted by the hydraulic press. So these are the steps that you're supposed to take, and with these steps, you can actually have your final answer as it is, guys. As we can see, it was pretty clear. Then we move on to the other question, which is on 6.32. So you're just going to utilize or take advantage of this space that we have here. So I'm just going to remove this. Okay, so let's see the other part that we are given here. On 6.32, we are given now to calculate the distance moved by the ram after 60 working strokes. So take note here, we now have the number of strokes, and the number of strokes is equivalent to 60. All right, calculate the distance moved by the ram. Okay, that is, we are referring to the h, the distance. In this case, already they used the capital letter H for the stroke length. So take note, they used the H, so we are not going to use this as a capital letter H. We are going to use even small letter h for the distance moved by the ram. Okay, so we know that the volume is actually the same that you're going to have. Okay, so we're going to have our volume as the area, that is d squared times h. Okay, so we're going to have d squared times h times the number of pumping strokes. So we're going to multiply by the number of strokes, that is the working strokes or pumping strokes. So we've got the number of working strokes here, which is equivalent to d squared times h. I explained about this formula before. So here, let's just use small letter h here. So this is representing the side of the plunger. Take note here. Okay, I need this one. So here it's representing the side of the plunger, the volume that we have on the plunger side, and this is representing the ram. So the distance moved by the ram, that is this h here. So to find h, what can we do? We just need to divide by d squared both sides. So if we cancel, we are going to have h as the height that we have on the ram. So remember, it was supposed to be capital letter H, but already they used the capital letter H for the plunger. So that's why I use this one as a small letter, okay? But it's supposed to be a capital letter for this one, okay? So it is going to be d squared times the h, which is on the plunger, which is our stroke length, times the number of pumping stroke or the number of strokes. All right, then we divide by d squared, the diameter on the ram. So by this, we can substitute. Remember, d squared is on the plunger and the diameter on the plunger is 0.025. So we are going to have this as 0.025 squared times h, which is our stroke length. So this indication, you must know what is important is this represents the stroke length. Whether they wrote this as L, as H, which is a capital letter or a small letter h, that one does not matter. What you need is to understand what it means actually. So this is your stroke length of 0.04 meters times the number of pumping strokes. We are given that the working strokes that we have is 60. So we're going to multiply by 60 over d squared, which is the diameter that we have on the ram. And on the ram, we've got 0.105 in meters. You use the one that is in meters, not in millimeters, okay? And this is d squared, so we are going to square the answer. So this is going to give us the distance moved by the ram. So if you use your calculator properly, you're going to obtain something like 0.136 if you round off properly in meters. So that was the distance which was moved. So this is question 6, working on hydraulics, engineering science, and 3. So as you can see, we have to revise. Hydraulics is all about the formulas. I always say this, revise your formulas as much as you can. This topic is an application of formulas. You need to know the exact formula to use and how to transpose the formula from your mathematics there. You must work out how to transpose a formula, and that is the most important part that you have. So that's what we had, guys, from Maths on African Motives. Till we meet again. Ooh.